Hi, I'm Bob Scher, and I'm here with Mike and Greg from Oakhurst Electric here in Long Branch and Deal, New Jersey. And we are here to do some testing and comply with a New Jersey code that says that the grounding and bonding integrity of multiple dwelling swimming pools, that is a swimming pool used for more than, and I think the spec says 4 people, I could be wrong. I want to introduce you to Mike and Greg. Why don't you guys just take a walk over here so they can see you. They'll be doing the test. We'll be doing the test. This is Greg.
How we doing?
That's Mike. And we'll be doing the test on using an AEMC 4620 ground tester. We have it set up, and we'll start by demonstrating how the connections are made. Let's go inside to the pump area and see where the connection to the ground is made. So here, what we're looking at here is the pump area for the pool, and we're looking at the ground. That's the ground that we're going to check the continuity and the bonding integrity. Now let's connect the unit to the ground. This is Greg now connecting the ground from the instrument to the ground on the swimming pool pump. This is the AEMC 4620. It is a digital unit that measures 4-pole, 3-pole, and 2-pole ground testing. We can either do soil resistivity, we can either do ground rods. In this case, we're doing a 2-pole test to test the integrity of the ground and the bond. You'll see that the green wire is the ground wire, and that wire is connected to the pump, as you saw Greg make that connection. Now we'll go outside to the pool, and we'll look at the blue wire, which now will be connected to any and all possible ground and bonding connections at the pool. Now we're going to connect the blue spool to the grounding on the ladder insert to confirm whether or not the connection between the bond and the ground is an integral and continuous connection. And now we'll go inside and make the measurement. Thank you, Mike, for doing that. Having the connections made, we will now check what the resistance is between the ground here at the pump and the ground outside by the water. And Greg, if you can do the honors. And as we notice, the resistance we read, by the way, includes the resistance of the spool. So it looks like 4.5 ohms. We deduct from that 4 ohms approximately. And so the reading of resistance is approximately a half an ohm. Good test. And now we'll make another connection outside and do another test. We moved over to a different part of the pool. We have to test every possible part that touches the water. I think the code says within 5 feet. And we're going to test each side of this ladder. We're now going to make the test and look and see what the resistance is, how well the continuity between the ground on the pump and the ground at the swimming pool. So Greg, if you can proceed with the test. And as we zero in on the number, we see a number of 14.4544, which is the same for both cups on that ladder. Deduct approximately 4 ohms, and there's a 10 ohm resistance. Thank you, Greg. So now we're doing a test to see whether the ladders are connected, whether there's an integral and continuous bond between each ladder entryway into the pool. And by doing this, we're checking the integrity of all of the grounding and all of the wiring. And now let's look at the unit and let's do the test. We'll ask Mike to do the test and read what is happening. So these are the tests that we perform in order to meet the code requirements for commercial swimming pools. And I think you've seen that you try to test every opportunity where electricity is connected, where grounds are connected, and where bonding is of concern. We've done the test. We thank Oakhurst Electric for the opportunity. We thank them for the privilege of using the AEMC 4620 and for taking the time. If you have any more questions and you'd like to talk about this opportunity, please call us. Thank you.